because it seems that the quickest way to improve your verbal reasoning is to shove a tissue up your left nostril. So let's see how these tissues have worked. Consider, right, an n-dimensional hypercube and connect each pair of vertices to obtain a complete graph of 2 to the power n vertices.
Each of them?
Yeah. Then colour each of the edges of this graph using only the colours red and black. That's my question, what is the smallest number, the smallest value of n for which every possible such colouring must necessarily contain a single-coloured, complete subgraph with 4 vertices which lie in a plane?
6.
That is exactly what people used to think. That's amazing. Brilliant.
Further.
Absolutely extraordinary.
Further up there, further.
Yeah, until 2003, most graph theorists thought the correct answer was probably 6.
I can only apologise.
But...
Coming in here with your old graph theory knowledge, how dare you?
It's so difficult, isn't it, when you've got a busy showbiz lifestyle like yours to keep up with the graph theory?
Yeah.
It's probably only 8 or 9 hours a day you're devoting to it now.
Yeah.
Well, I have to say, I've got Graham's number.
6.
Have you got Graham's number?
No. I don't have that sort of relationship.
You've not got that sort of relationship. There is such a thing, which is relevant to this, as Graham's number. But it's bigger than 6.
Of course it is.
It is really big. Try and think of a really, really big number.
17.
It's... Do you know what? It's even bigger than that. This number... All right, now get hold of this idea. This number is so big that all the material in the universe, right, couldn't make enough ink to write it out. It's called Graham's number, named after a fellow called Ronald Graham. And weirdly enough, scientists know that it ends in a 7. Which is really strange.
But how would it end in a 7? Could you just turn that into an 8 and then it's a bigger number?
It didn't say it was the biggest number ever. It's just this is Graham's number, which is huge. You could have other Graham's number. You could have Norton's number.
Graham Norton. I made it an 8 at the end.
But you can remove your tissues, incidentally. No.
I think I'll miss it now.
Oh, will you? OK. Keep it.
I'm worried about what might come out when I pull it.
The fact is, this problem is a graph problem, it seems. Imagine a cube with lots of different dimensions, where each corner of the shape is connected with red or black lines to every other. What is the fewest number of dimensions so that you must end up with at least one single-coloured square with the same coloured diagonals? Until 2003, they thought it was 6. Now it's been shown that it must be at least 11. The answer may well now be 12, but it's somewhere between 11 and Graham's number, that enormous number. Which is... There's quite a lot of room for error, isn't
Yeah,
it?
that's not really an answer, is it?
The greatest mathematical minds in the world just don't know what the answer is. It seems...
I don't understand the question.
Neither do I. Neither do
I
I.
imagine they don't either, to be honest. And they're really hoping nobody checks.
What they do know is it ends in a 7. Now, what music can you play to your children?